Chapter 3, Lesson 1, Constant Rate of Change. You will be able to identify proportional and non-proportional linear relationships by finding a constant rate of change. Linear relationships have a constant rate of change. The balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. So when we're talking about rate of change, we want to know the change in our y value over the change in our x value. So if we look here for a pattern, what happens is it's subtracted by 30 every time. And on the left-hand side, or our x values, we are adding 3 every time. So our rate of change would be, in this scenario, the balance over the number of transactions. Since they're all the same, negative 30 over positive 3 equals negative 10. So is it linear? Yes. And by linear, we mean, is it a straight line? Yes, it's a straight line, and the constant rate of change is negative 10. More specifically, it's negative $10 per transaction. Is the relationship linear? If so, find the constant rate of change. If not, explain your reasoning. Minus 5, minus 4, and minus 4. Over here, it looks like all plus 5. No. On the left-hand side, it's all going up by the same amount, and on the right-hand side, it is not decreasing by the same amount. Therefore, this is not linear. And the reason? Because it does not have a constant rate of change. And that whole thing is our answer. Letter C. Is the relationship linear? If so, find the constant rate of change. If not, explain your reasoning. So for constant rate of change, the best thing to do is to create a table with your x and y values. And to do that, look at each point. This point is 8, 80. The next point is 16, 60. And the next point is 24, 40. To see if there's a constant rate of change, 80 to 60 is minus 20, and 60 to 40 is also minus 20. And with our x values, it looks like plus 8 to 16 and plus 8 to 24. So yes, it's linear. Our constant rate of change is negative 20. And again, we could say it drops 20 volunteers per minute. Oh, actually, hang on a minute. Mistake there. Jumping ahead of myself. We have to take our negative 20 divided by 8. So we have negative, negative 20 divided by 8 looks like negative 2.5. That's more realistic. So negative 2.5 is our constant rate of change, and it looks like this relationship drops 2.5 volunteers per minute. Proportional linear relationship. To determine if two quantities are proportional, compare the ratio change in y over change in x for several pairs of points to determine if there is a constant ratio. When using change in y over change in x, if the ratio is reduced to the same fraction every time, the relationship is proportional. Sometimes there won't be an obvious pattern. Determine whether the relationship between the two quantities shown in each table or graph is linear. If so, find the constant rate of change. If not, explain your reasoning. I'm actually going to add in our directions here. It says show if it's linear, but I also want to know if it's proportional. So I'm going to add that direction in here. Okay, we're still going to start it the same way. We have to see if it's linear first. So to see if it's linear, we have to see what the change is. From 15 to 24 is plus 9. 24 to 36 is plus 12. 36 to 72 is plus 36. Over here, 5 to 8 is plus 3. 8 to 12 is plus 4. And 12 to 24 is plus 12. Now, it might look like it's not linear, but we need to take each set and see if it works out. Because they don't go up by a certain amount on your y's or your x values, let's take each one individually. Let's do 9 and 3. So 9 divided by 3 is 3. Okay. And the next one, 12 divided by 4 is 3. And the last one, 36 divided by 12 is 3. And again, I'm getting these numbers from here. 9 and 3, 12 and 4, 36 and 12. So this right here tells me it's linear. So it is linear. Now we need to figure out if it's proportional. And here's how we do that. Now we just take the numbers in our chart. 15 over 5. We do 24 over 8. We do 36 over 12. And we do 72 over 24. 15 divided by 5 is 3. 24 divided by 8 is 3. 36 divided by 12 is 3. And 72 divided by 24 is also 3. Because these are also the same, this means it's proportional. So, is it linear? Is it proportional? Yes. And the constant rate of change is 3. Letter B. Again, I want to know if it's linear and proportional. So we need to find the pattern in our distance and in our time. Our time is easy. We'll start with that one. That goes up by 1 every time. Now to figure out how much it goes up by, you can absolutely use a calculator and subtract. So 19.6 minus 4.9 is 14.7. That goes up. And the next one, we've got 44.1 minus 19.6, which is 24.5 for the second one. And the third one, 78.4 minus 44.1 is 34.3. So take each one. We have 14.7 over 1, which equals 14.7. We then have 24.5 over 1, which equals 24.5. And we have 34.3 over 1, which equals 34.3. Now, I do not have to take this a step further. This is not linear, and because it's not linear, it can never be proportional. So our answer here would be no, because it does not have a constant rate of change. Okay. Letter C. Again, I want you to create a table of values here. This is at 215. Yep, looks like it counts by 15s. So 215. The next point looks like 430. And the last point looks like 645. First, let's see if it's linear. It's adding by 15 on this side and adding by 2 on this side. So 15 over 2 is 7.5. So I know it's linear. And is it proportional? To find out if it's proportional, look at each point separately. 15 over 2 is 7.5. 30 over 4 is also 7.5. And 45 over 6, let's do that one on the calculator, is also 7.5. So yes, it's linear. Yes, it's proportional. Our constant rate of change is 7.5. It's linear because the change in y over change in x has a constant rate of change. And it's also proportional because our y divided by x tells us it's proportional. We have the same amount, which both means that the constant rate of change is 7.5. Match the table with its rate of change. So here we're just finding the rates of change and then matching them up. 20 to 30 and 30 to 40 is plus 10. 170 to 162 is minus 8. 162 to 154 is also minus 8, which would put this at negative 8/10, which would be negative 0.8, which means this matches here. Here our change goes up by 1 both times, and our change here is up by 10. So 10 over 1, which equals 10. Our constant rate of change is 10. The next one, it increases by 2. And here it increases by 0.5. So 0.5 over 2, which is 0.25. And over here it increases by 5 each time. And here it increases by 12. So we have 12 over 5, and if I had to take a guess, the only one left is 2.4.